it is permissible to use number 8/3 with ground service entrance aluminum cable for a range installation in a dwelling unit. The ampacity of number 8 American wire gauge copper wire is 40 amps and a 75 degrees Celsius ambient temperature, which matches the 40 amp rating of the range. Service entrance cable is typically rated for 75 degrees Celsius. It is a type of non-metallic sheet cable with a thermoplastic insulation and a polyethylene jacket. The temperature rating of the device terminals involved in the installation, such as the range receptacle, must be at least equal to the temperature rating of the cable and the conductor it contains. In this case, the device terminals must be rated for 75 degrees Celsius or higher. Based on the provided information, it is permissible to use number 8/3 with ground service entrance aluminum cable for a range installation in a dwelling unit. The cable and conductor are rated for 75 degrees Celsius, and the device terminals are rated for the same temperature. The 40 amp breaker is also appropriate for this installation. To elaborate, let's delve into the specific considerations for using number 8/3 service entrance aluminum cable for a range installation. Firstly, the ampacity of the conductors must be sufficient to handle the load of the range. Number 8 American wire gauge aluminum cable, when used with 75 degrees Celsius terminations, typically has an ampacity of 40 amps. It's crucial to verify the specific ampacity rating based on the cable manufacturer's specifications in the National Electrical Code, NEC Table 310.15b16, or the appropriate table for aluminum conductors, which would be Table 310.16 if copper. Secondly, the overcurrent protection device, in this case a 40 amp circuit breaker, must be sized appropriately to protect the conductors. The breaker should not exceed the ampacity of the conductors, but it can be sized up to the next standard size if the conductor ampacity doesn't match a standard breaker size. However, for a range circuit, specific rules may apply, allowing for a higher breaker rating based on the range's nameplate rating and demand factors. Thirdly, the temperature rating of the service entrance cable and the connected devices is paramount. Service entrance cable is generally rated for 75 degrees Celsius. The terminals of the range receptacle and the circuit breaker must also be rated for at least 75 degrees Celsius. This ensures that the connections can safely handle the heat generated by the current flow. The NEC Section 110.14 code specifies the temperature limitations for conductors. You must select equipment that is rated for the application and install it accordingly. The 75 degrees Celsius rating is common for many devices, but it's essential to confirm the markings on the equipment. Additionally, when working with aluminum conductors, it's critical to use connectors and terminals that are specifically listed and labeled for use with aluminum. These connectors are designed to prevent corrosion and ensure a reliable connection. An antioxidant compound should also be applied to the aluminum conductors before making the connection to further prevent corrosion. The NEC provides guidelines for proper termination and splicing of conductors in Article 110.14. Furthermore, the installation must comply with all applicable local codes and regulations. These codes may have additional requirements or restrictions on the type of cable and wiring methods that can be used. It's always best to consult with a qualified electrician or electrical inspector to ensure compliance. The grounding of the range circuit is another critical aspect of the installation. The service entrance cable includes a grounding conductor, which must be properly connected to the grounding system of the electrical panel and the range receptacle. This provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. The NEC Article 250 covers the requirements for grounding and bonding. In summary, using number 8/3 with ground service entrance aluminum cable for range installation is permissible if the ampacity of the conductors is sufficient for the range load, the overcurrent protection device is properly sized, the temperature ratings of the cable and devices are compatible, and all applicable codes and regulations are followed. Always prioritize safety and consult with a qualified electrician to ensure a safe and compliant installation. Remember to check the local codes and regulations of New Jersey. These codes may vary from the NEC and could impose additional requirements or restrictions on the installation. Always adhere to the strictest guidelines to ensure safety and compliance. The use of service entrance cable for a range installation is common, but it's crucial to understand the specific requirements and limitations. This type of cable is designed for use as service entrance conductors, but it can also be used for other applications, such as supplying power to a range, as long as it meets the necessary requirements. The number 8/3 designation indicates that the cable contains 3 conductors, a hot, a neutral, and a grounding conductor. The number 8 refers to the American wire gauge size of the conductors. The service entrance aluminum cable is typically used in residential applications, where it is run from the meter to the main electrical panel. From the main panel, branch circuits are run to various appliances and devices throughout the house, including the range. When installing the service entrance aluminum cable for a range, it's important to follow the manufacturer's instructions and the NEC guidelines. The cable must be properly supported and protected from physical damage. It should also be installed in a manner that prevents moisture from entering the cable. The connections to the range receptacle and the circuit breaker must be made using appropriate connectors and terminals. These connectors should be listed and labeled for use with aluminum conductors and should be tightened to the manufacturer's specified torque. Over-tightening or under-tightening the connections can lead to problems such as overheating and loose connections. The grounding conductor in the service entrance aluminum cable must be properly connected to the grounding system. This is typically done by connecting the grounding conductor to the grounding bus bar in the electrical panel and to the grounding terminal on the range receptacle. The grounding system provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. When selecting a circuit breaker for the range circuit, it's important to choose a breaker that's properly sized to protect the conductors. The breaker should not exceed the ampacity of the conductors, but it can be sized up to the next standard size if the conductor ampacity doesn't match a standard breaker size. However, for a range circuit, specific rules may apply, allowing for a higher breaker rating based on the range's nameplate rating and demand factors. Consult the NEC for specific guidance on sizing circuit breakers for range circuits. The temperature rating of the service entrance aluminum cable and the connected devices is another important consideration. The service entrance aluminum cable is typically rated for 75 degrees Celsius, which means that it can safely handle temperatures up to 75 degrees Celsius. The terminals of the range receptacle and the circuit breaker must also be rated for at least 75 degrees Celsius to ensure that the connections can safely handle the heat generated by the current flow. In addition to the above considerations, it's also important to comply with all applicable local codes and regulations. These codes may have additional requirements or restrictions on the type of cable and wiring methods that can be used. It's always best to consult with a qualified electrician or electrical inspector to ensure compliance. In conclusion, using number 8/3 with ground service entrance aluminum cable for a range installation is permissible if the ampacity of the conductors is sufficient for the range load, the overcurrent protection device is properly sized, the temperature ratings of the cable and devices are compatible, and all applicable codes and regulations are followed. Always prioritize safety and consult with a qualified electrician to ensure a safe and compliant installation. The NEC also provides tables and guidelines for directing conductors based on the number of current carrying conductors in a raceway or cable. If the service entrance aluminum cable is installed in a manner where it is bundled with other cables, the ampacity of the conductors may need to be derated to prevent overheating. Consult the NEC for specific guidance on derating conductors. Furthermore, the NEC requires that all electrical connections be made in a neat and workmanlike manner. This means that the connections should be clean, tight, and properly insulated. Loose or poorly made connections can lead to problems such as overheating, arcing, and electrical fires. Always take the time to make sure that all electrical connections are made properly. The NEC also provides guidelines for the use of flexible cords and cables. Flexible cords and cables are typically used to connect appliances and equipment to the electrical system. However, the NEC restricts the use of flexible cords and cables in certain applications. For example, flexible cords and cables are not allowed to be used as a substitute for permanent wiring. When using flexible cords and cables, it's important to follow the NEC guidelines to ensure that they are properly installed and protected from damage. In addition to the NEC, there may be other standards and guidelines that apply to electrical installations. For example, Underwriters Laboratories publishes standards for electrical products and equipment. These standards are often referenced in the NEC and are used to ensure that electrical products and equipment are safe and reliable. When selecting electrical products and equipment, it's important to choose products that are UL listed or certified. The UL listing mark indicates that the product has been tested and meets the requirements of the UL standard. Another important aspect of electrical safety is the use of ground fault circuit interrupters, GFCIs. GFCIs are devices that are designed to protect people from electrical shock hazards. GFCIs work by monitoring the current flowing through a circuit. If the current flowing through the circuit differs from the current returning to the source, the GFCI will trip and shut off the power to the circuit. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electrical shock. It's important to install GFCIs in these locations to protect yourself and others from electrical shock hazards. Electrical safety is a critical aspect of any electrical installation. It's important to follow all applicable codes and regulations and to take the necessary precautions to protect yourself and others from electrical shock hazards. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge and experience to safely and properly install electrical wiring and equipment. In addition to the technical aspects of electrical installations, it's also important to consider the aesthetic aspects. Electrical wiring and equipment should be installed in a manner that is neat, clean, and visually appealing. Exposed wiring and haphazard installations can be unsightly and can detract from the overall appearance of a building. Take the time to plan the electrical installation carefully and to install the wiring and equipment in a manner that is both safe and aesthetically pleasing. The selection of electrical boxes and fittings is another important consideration. Electrical boxes and fittings are used to protect electrical connections and to provide a means of mounting our electrical devices. There are many different types of electrical boxes and fittings available, and it's important to choose the right type for the application. For example, metal electrical boxes are typically used in areas where there is a risk of physical damage, while plastic electrical boxes are typically used in areas where there is no risk of physical damage. The electrical boxes and fittings should be properly sized to accommodate the wiring and devices that will be installed in them. It's also important to make sure that the electrical boxes and fittings are properly grounded. The grounding of electrical boxes and fittings is essential for electrical safety. It provides a path for fault currents to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. Always make sure that electrical boxes and fittings are properly grounded before installing any wiring or devices in them. The use of proper wiring methods is another important aspect of electrical installations. There are many different wiring methods available, and it's important to choose the right method for the application. For example, non-metallic sheet cable is typically used in residential wiring, while metal conduit is typically used in commercial and industrial wiring. The wiring method should be installed in accordance with the NEC and all applicable local codes and regulations. It's also important to make sure that the wiring is properly supported and protected from physical damage. Proper wiring methods are essential for electrical safety and reliability. The labeling of electrical panels and circuits is another important consideration. Electrical panels and circuits should be properly labeled to identify the circuits that they serve. This makes it easier to troubleshoot electrical problems and to turn off the power to specific circuits when necessary. The labeling should be clear, concise, and easy to read. It's also important to keep the labeling up to date. When circuits are added or changed, the labeling should be updated accordingly. Proper labeling of electrical panels and circuits is essential for electrical safety and convenience. The use of surge protection devices is another important aspect of electrical safety. Surge protection devices are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. Surge protection devices work by diverting the surge current to ground, preventing it from damaging electrical equipment. Surge protection devices are available in a variety of different types and sizes. It's important to choose a surge protection device that is appropriate for the application and to install it in accordance with the manufacturer's instructions. Surge protection devices can help to protect valuable electrical equipment from damage caused by voltage surges. The inspection of electrical installations is an important part of the electrical safety process. Electrical inspections are typically performed by qualified electrical inspectors who are trained to identify electrical hazards. Electrical inspections can help to ensure that electrical installations are safe and in compliance with applicable codes and regulations. It's important to schedule an electrical inspection before energizing a new electrical installation or making any significant changes to an existing installation. Electrical inspections can help to prevent electrical fires and electrical shock hazards. Finally, remember that electrical work can be dangerous. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge and experience to safely and properly install electrical wiring and equipment. Always prioritize safety when working with electricity. By following these guidelines, you can help to ensure that electrical installations are safe, reliable, and in compliance with all applicable codes and regulations.